x-intercepts can be found by taking the numerators and setting them equal to 0. So for this example, I'm going to factor this into x plus 1 and x minus 1 all over x minus 3. I can't simplify anything, so there's no holes. I can see that I would have a vertical asymptote at x equals 3. And also, by the way, in this particular problem, look at the numerator on top is greater than the numerator on the bottom. So if we go back to that, we can see that when the numerator on top, let's see where I put that form so you can see it nicer. Hold on one second. The numerator on top is greater than the numerator on the denominator. There is no horizontal asymptote. Please write no horizontal asymptote. In this situation, there is never a horizontal asymptote. Okay? We will have a slant asymptote, but no horizontal asymptote. Okay, so I come back here. Now, how do I find the x-intercept? So the x-intercept is once it's in factor form, set each one of these equal to 0, and we have an x-intercept at 1, and we have another x-intercept at negative 1. So x-intercepts are formed on top. We determine the horizontal asymptotes in these two situations when the numerator on top is less than the numerator on the bottom for the degrees. When the degrees of the numerator and denominator are equivalent, we're able to take the leading coefficients and divide. In this situation, there is never going to be a horizontal asymptote, but there will always be a slant asymptote. Okay, let's get started here, and let's get back to this next example. We are only asked to find the zeros, but let's go through everything we know. So, in this particular form, we can see that the degree on top is the same as the degree in the bottom. So what's going to happen when that's the case? When that's the case, we're going to have a horizontal asymptote of y equals, and we're going to divide the leading coefficient, so 1 over 1. So y equals 1 is going to be the horizontal asymptote. It also is going to be opposite the end behavior. As it goes to the far left, it's approaching 1. As it goes to the far right, it's also approaching 1. The vertical asymptotes, we can't cancel anything out, so we have no holes. And when I set each of these equal to 0, I have equations of x equals 7 and x equals negative 2. They would be the vertical asymptotes. Now, there is no slant asymptote. Remember, slant asymptotes only occur when the numerator, the degree of the numerator is greater than the degree of the denominator. We don't have that, so I can cross that out. Where do I find the x-intercepts? Well, in this form, it's really nice. I factored it really quickly for us, and we set each of these equal to 0, and we have x-intercepts at 5, 0, and at negative 3, 0. Let's look at the next. All right, let's take a look at this next example. So I went ahead and I took this original numerator, and I was able to see that we have even coefficients, and so I factored it 2, and then I recognized that this factors into x minus 5 and x plus 3, and the denominator easily factors into x plus 3 and x minus 1. So whenever we have the degree on top is the same as the degree on the bottom, we're going to have a horizontal asymptote. When there's horizontal asymptote, there's never going to be a slant asymptote, because slant asymptotes only occur when the degree in the numerator is greater than the degree in the denominator. So that's why I'm able to cross this out. If there's a slant, there's no horizontal. If there's a horizontal, there's no slant. All right, here we go. Going back here, so how do I figure out the slant asymptote? 2 divided by 1 is 2. So this is the slant asymptote. The equation is y equals 2. Don't just say 2, it's y equals 2. Now in factored form, I can see that I'm able to simplify x plus 3 on the top and x plus 3 on the bottom. A lot of students like to use the word cancel out because that's what appears happens. Really, they simplify to 1. So I'm left with 2 times x minus 5 over x plus 1. I know, because I'm able to simplify these, that I'm going to have a hole at negative 3, 0. So at negative 3, 0, we're not going to see a 0 here. It's going to say undefined. There's going to be no output value that goes with an x value of negative 3. There's going to be no output value. You should have put undefined and not 0. How am I able to then achieve